Introduction. Centripetal Force, Universal Law of Gravitation, Free Fall, Influence of Gravitational Force of Earth. In this chapter, we shall learn about gravitation and the Universal Law of Gravitation. We shall discuss the motion of objects under the influence of gravitational force on the Earth, how the weight of a body varies from place to place, and conditions for objects to float in liquids. I always thought, why the egg fall down when I try to juggle it while cooking? An object, when thrown upwards, reaches a certain height and then falls downwards. It is said that when Newton was sitting under a tree, an apple fell on him. The fall of the apple made Newton start thinking. He thought that if the earth can attract an apple, can it not attract the moon? And now, we all know that the moon goes around the earth. The motion of the moon around the earth is due to the centripetal force. The centripetal force is provided by the force of attraction of the earth. If there were no such force, the moon would pursue a uniform straight line motion. Centripetal force. The force that accelerates and keeps the body moving along the circular path and acting towards the center is called the centripetal force. It is seen that a falling apple is attracted towards the earth. Does the apple attract the earth? Yes. According to the third law of motion, the apple does attract the earth. But according to the second law of motion, for a given force, acceleration is inversely proportional to the mass of an object. The mass of an apple is negligibly small compared to that of the earth. So we do not see the earth moving towards the apple. The planets of solar system revolve around the sun due to a force. Newton concluded that not only does the earth attract an apple and the moon, but all objects in the universe attract each other. This force of attraction between objects is called the gravitational force. Universal Law of Gravitation. Every object in the universe attracts every other object with a force which is proportional to the product of their masses and inversely proportional to the square of the distance between them. The force is along the line joining the centers of two objects. By combining equations, we get F is proportional to capital M into small m upon d square. Or can say F is equal to G multiplied by capital M into small m upon d square, where G is the constant of proportionality and is called the universal gravitation constant. Therefore, G is equal to F into d square upon capital M into small m. The SI unit of G is nm square kg raised to power minus 2. And the accepted value of G is 6.673 into 10 raised to power minus 11 nm square kg raised to power minus 2. Importance of the Universal Law of Gravitation. The Universal Law of Gravitation successfully explained several phenomena which were believed to be unconnected. The force that binds us to the earth, the motion of the moon around the earth, the motion of planets around the sun, and the tides due to the moon and the sun. Free fall. Take a ball, throw it upwards, it reaches a certain height, and then it starts falling down due to gravitational force. Whenever an object falls towards the earth under gravitational force alone, we say that the objects are in free fall. While falling, there is no change in the direction of motion of an object. But due to Earth's attraction, there is a change in the velocity. Any change in velocity involves acceleration. This acceleration is due to the Earth's gravitational force. Therefore, this acceleration is called the acceleration due to gravity. It is denoted by g and its unit is ms raised to power minus 2. Let mass of the ball is m and acceleration due to gravity is g. We know that force is equal to mass into acceleration. Therefore, F is equal to mg. But we have seen that F is equal to g multiplied by m into m upon d square. F is equal to g multiplied by capital M into small m upon d square. Put value of F is equal to mg. We get mg is equal to g multiplied by capital M into m upon d square. Cancel small m of both sides. Therefore, acceleration due to gravity will be g is equal to capital G multiplied by capital M upon d square. If an object be on or near the surface of the earth and r is the radius of the earth, thus for objects on or near the surface of the earth, force F is equal to mg is equal to capital G multiplied by capital M into m upon r square. Motion of objects under the influence of gravitational force of the earth. As we know now, an object experiences acceleration during free fall. This acceleration is independent of mass of an object. This means that all objects, hollow or solid, big or small, should fall at the same rate. As g is constant near the earth, we can use a for uniformly accelerated motion of objects instead of g. The following equations are valid for a. This is all about this subtopic.